So now we introduce the concept of a multi-industry economy, and we are going to introduce an enormous amount of heterogeneity, but not heterogeneity in the sense units are draws from a common distribution. We are going to introduce a fundamental heterogeneity. The analogy is to go to models of international trade from closed economy models, that kind of heterogeneity. But we're going to talk about industries that are fundamentally different, okay? And I think that this is exactly the tool that you need to address the question that you put on the table, which in some sense has been staring us in the face for decades, but to my knowledge, we never solved. So let's see if we make progress. So this is the introductory slide, and Klaus had a much better introduction to this topic than with that question than I have in this slide. So let's move on. All right, so we are going to go to set up a multi-industry economy. And the way to do it, a simple way to do it is, remember in this model, there is the household, there is a sector that produces homogeneous final good, assembling intermediate goods. So what we're going to do is we are going to introduce an extra layer in this vertical production structure. So layer one that defines industries. Representative competitive firm produces the homogeneous final good G, which is our GDP in this economy. And now we say that it does it with a Cobb-Douglas production function defined over differentiated intermediate goods, and where capital J is the number of industries in the economy. And then this new parameter phi J is the elasticity of industry J in the production of GDP in this economy. This is very standard. Now, this outer layer must be Cobb-Douglas for the purpose of this exercise, because I want to have industries that can grow at different rates without an industry taking over the entire economy. Okay, so that's and again, this structure is familiar is very common in international economics, all sorts of other fields where people study problems of this class. And layer two is essentially the same as in the baseline model, but industry J, okay, produces its output G sub J by assembling intermediate components that are industry specific. Okay, so that's the structure of industry here. And they do it with the CES production function that I use in the baseline model. The interesting thing here is that every equation that I showed you before with a parameter, now that parameter, every single parameter, with a couple of exceptions, gets a subscript J. Okay? All of the parameters are industry specific. So there is industry specific law of variety, industry specific elasticity of substitution. Okay? And then this gives me my demand system across the intermediate, the suppliers of the industry specific components that producer J then supplies to the final producer. Okay, that's the structure. And that's where I'm introducing the heterogeneity that I think you, Klaus, were after. All right, then within industry J, there are differentiated suppliers. So I index by I. And this data should have a subscript J. So there is a production technology in industry J that is industry specific. Okay? And so there might be industries with low elasticity of TFP with respect to fair knowledge, industries with low fixed operating costs versus industries with very large fixed operating costs. That's the kind of thing that you were after, I think, Klaus. And then there is an R&D technology with industry-specific parameters. Okay, And I'm going to go with the kj being the arithmetic average to go back to the baseline model, very simple, that is an analytical solution. I showed you in the previous hour and a half, how to complicate the hell out of these things, introducing deviations from the very simple environment. All right, now within each industry, basically, the funny thing is this: each industry is basically a replica of the economy that I showed you before. The interesting thing is then there is a free entry condition that is industry specific. I can make the entry cost industry specific. So there could be industries with high entry costs, industries with low entry costs, and we already have an intuition for about what that does to the equilibrium. Important thing is that aggregation. Excuse me, before that, so there is a demand for labor in production by within industry, the equilibrium is symmetric. And then we have the set of equations that describe the equilibrium in the baseline model that didn't have the subscript. Now all of those equations show up with the industry-specific subscript. Okay. Now, and these are the rates of return. If you look carefully at these two equations, they are the same as in the baseline model. You just add in the industry-specific subscript. One point that I didn't mention, but that it's very important to achieve tractability, is that spillovers are within industry. I have no problem with this assumption, although I know that some people will criticize it, because the evidence is overwhelming that firms learn mostly from other firms in the industry. That's one of the facts reported systematically by people who look at data. But that's if you take away that assumption, then things become much more complicated. All right, so the beauty is that aggregation works like a charm. I set again the wage equal to 1, so that everything is measured in units of labor. No arbitrage tells me that I should equalize all rates of return. Then I have the firm portfolio. Notice that now the portfolio is the summation of a heterogeneous equity, because equity in industry J is different from equity in industry I, different from J, etc., etc. But the important thing is that the free entry condition gives me again this equality. And because the expenditure shares are constant, that comes from the outer Cobb-Douglas outer layer of aggregation, then we have this beautiful aggregation result. In my opinion, the wealth is just the sum, and then you go through the strings of equalities, and you obtain again the wealth is proportional to household expenditure. We know what that does from the baseline model. This result then gives us that we will get that expenditure per capita jumps to its steady state value and remains constant there, and therefore the interest rate is constant at all times. And it doesn't get any simpler. And this is the employment. Industry employment is aggregate employment times the industry share. Okay, that's what I mean by aggregation works like a charm. There is a twist in this story, however, because this is a configuration where free entry holds in all industries. Remember from the baseline model that there is also an equilibrium where free entry doesn't hold. And in the single industry economy, that makes things just okay. You have 3 regions of state space. Here things get much more interesting, because now you have 2 configurations where free entry holds in all industries. I'm going to call it the free entry regime. And then free entry fails in at least one industry. It's sufficient that free entry fails in one industry that your equilibrium looks very, very different. Why? Because you don't have that aggregate wealth is proportional to household expenditure, consumption expenditure. Okay, so I'll try to give you the flavor of how it works. So the beauty is that as long as you are in the free entry regime, you basically have the same representation. Within industry, the economy behaves as the aggregate economy in the baseline model. So you get the same mathematical representation. Every industry parameter gets a subscript J. What parameter does not get the subscript J? Rho, because rho is the interest rate. And the interest rate is a general equilibrium object, not an industry-specific object. particularly when you impose no arbitrage. The thresholds are industry specific. And in fact, I can have industries where I can invert the ordering. I'm not going to do that because it complicates things, but that's essentially the structure that we have here. Okay, then there is an industry-specific endogenous growth condition, an inequality in the parameters. There is an industry-specific steady-state value of firm size, and that's the attractor of these dynamics, okay, which is piecewise linear. So again, I can solve it by hand. And this steady-state value of industry-specific value of firm size gives me the industry-specific growth rate of firm growth rate. Okay, so this is the average growth rate of the firms in this industry, and it changes across industries. Okay, that's the heterogeneity that we have here. Again, no scale. Scale invariance is an industry level result here. It's not an aggregate property, a property of the general equilibrium. Scale invariance is a property that holds industry by industry here. Okay. Okay, so this is the kind of phase diagram that you can draw. I'm going to discuss later what happens potentially in this region where there is at least one industry that is not in free entry equilibrium. Okay, so that's the structure, and so then you basically solve. The solution procedure is the same that we follow to solve the aggregate model. Okay, the difference is that you don't have an analytical solution for the date at which the free entry regime holds because that date is the max between the industry specific dates at which the free entry condition starts holding in each industry. Okay, so that's why I need a little bit more nuance and more attention to detail there. So in each industry there is a price index, which is the price index, the CES price index of the prices charged by the individual suppliers to that producer. So output per worker in industry J this is just a variant of the baseline model. And there is an industry specific TFP object that is the usual function of the two dimensions of technology here. So I can define industry-specific TFP. Then there is a growth rate of industry-specific TFP and the steady-state growth rate of industry-specific TFP. And in this model, I don't need to shut down population growth. Population growth is positive. It's the other parameter that doesn't get a subscript because it's an economy-wide parameter, not an industry-specific parameter. Again, scale invariance. So I can construct the growth function. And the difference here again is that every parameter that is industry specific gets a subscript J. Then I can look at a neighbor of the steady state with endogenous growth. Then my dynamics reduces to this super simple representation with these composite parameters. I get this solution of the linear differential equation. And then I can compute the time path of productivity, of the log of productivity within the industry, exactly as we do in the baseline model. So all I need is the initial gap, then the mechanics of the model gives me the time path of productivity. So then what is aggregate growth? Aggregate growth of GDP per capita in this economy is the aggregation, according to my Cobb-Douglas operator, of all the industry outputs. Okay. So I write it like this, then I pull out all of these terms that don't get an industry subscript. I think the C star should have an industry, a subscript J, and so remain inside. Then I can define aggregate growth. And so you take the log, take logs and time derivatives. So aggregate growth is the weighted sum of, at any point in time, aggregate growth is the growth rate of expenditure per capita plus the weighted sum across industries of TFP growth, okay? And in steady state, this term becomes constant. Why do I have this term here? Because remember that I want to keep in mind that there are equilibria where at least one industry is not in free entry, the free entry condition does not hold, and that in that equilibrium, expenditure per capita is not constant, but it needs to be computed from the equations of the model. So what's the utility flow here? Again, you separate things out, and you get that the representation is level effects, purely aggregate things, and then you basically have the weighted sum of utility coming from the different TFP coming from the different industries, and so your welfare then becomes a weighted sum of the steady state growth across industries discounted and the weighted sum across industries of the transitional dynamics component. Okay, so that's the aggregation part of the story. And so pretty much we already know from studying the single industry model how each one of these industries behave. But because of the heterogeneity in parameters, we can have a combination, all sorts of combinations of industries, including industries that do not activate firm innovation, and so have Z in steady state, they have Z hat J equal to 0. Okay, that's a possibility. By the way, since going back to Carmelo's question about policy things, so this in fact tells you that in this world, policy has two margins of action. You can think about policies that induce industries that already invest to invest more and grow faster. And you can imagine policies that induce industries in which firms are not investing to start investing and growing. So policy that pursue the activation of firm growth, and policies that pursue the enhancement of firm growth. Those are two different margins. And it comes from looking at the phase diagram, because if you have imagine the red line being an industry that converges to a steady state without firm growth, then you need to think about industry-specific interventions that could lift this red line to become like the black line, so that that industry converges to a steady state that exhibits endogenous growth. And because of the underlying parameter heterogeneity, I don't think there is a one-size-fits-all kind of policy message coming out of this framework. All right, so that's the first piece of the story. Okay, so let's look at what happens if at least one industry is not in free entry equilibrium. Remember the structural slam story that I told you last time? Some event causes the economy to go all the way to the left in the phase diagram. Now we can ask the question, is there some event, maybe aggregate, maybe firm specific, that can cause an industry like this to end up to the left of this threshold xn? This is the region where in that industry, the free entry condition fails. Okay? Then the discipline of this model is that you can still derive analytically what's going to happen in this situation. And the other thing is that there is a potential for contagion. The fact that one industry experiences a crash with a structural slump, in fact, can propagate to other industries. Why? Because in general equilibrium, all the industries are interconnected. In the free entry regime, that interdependence is a little bit muted by the fact that the free entry condition gives us constant expenditure per capita and constant interest rate. Remember when I told you that when there is a crash of an industry that gets into a situation of the market, of the economy, when it gets into a situation, too many firms given market size? Remember I told you that in that case there is a stock market crash? Now, what's happening here is that can play out in a single industry, an event that reduces drastically the size of the market in a particular industry, let's say industry one, okay? Then, by definition, that industry experiences a crash of the stock market valuation of the firms for the same reason I discussed last time, too many firms given the size of the market. But the important thing is that the stock market crash shows up in the budget constraint of the household as a drop in wealth, and therefore can spread through contagion to other industries. This is how you do it. You look at the budget constraint of the household here, and then you unpack wealth, okay? And so you write the left-hand side as the sum of this term in industry one, and then the other terms. So all of the other terms remain as in the baseline model, because in the industries J from 2 to capital J, the free entry condition holds, okay? That's what we're doing. So then we use the expression for the rate of return to equity to transform this equation into something in this expression over here that contains the profits of industry one, all these terms of industry one, and then this term over here, because now industry one has shut down completely firm investment and entry. Therefore, the number of shrinks in industry of firms in that industry is shrinking. Or delta here should have a subscript one, because it's an industry-specific parameter, okay? And then if you observe this equation, a bunch of things cancel out very nicely. And so that expression reduces to this formula over here. Then what you do is you use the Euler equation that comes from the consumption saving problem to take care of this part of the equation. And so all of these expressions, seemingly complicated, in fact gives you an expenditure per capita function, which is the analog of the one that we derived in the single industry economy, but now contains the state variable of industry one. Because remember, industry one is the one in trouble. And so industry one is the one that needs restructuring. And so industry one is going to drive the recovery process, as long as no other industry gets in trouble. But there is the potential of contagion. So let's do the exercise with industry one gets in trouble, no contagion, it's the only one that remains in trouble. And then what you do is you do basically the calculations that you do in the baseline model. Given that you have the expenditure function, you can construct the interest rate function as a function of the state variable. And then you can construct a phase diagram in 2 dimensions, firm size and expenditure per capita, which is the industry analog of the one that we studied last week for the single industry economy. So these are just the expressions for the equation in case people are interested in. I'm not going to go through the details because they're there and people can then look at the slides or buy the book when it's finally published. And the important thing is that all of this structure is going to, let me go to the phase diagram just to give you the flavor of what's happening. So the phase diagram says that in industry one, if you look at this phase diagram, it looks like the single industry economy. And that's exactly what's happening here. But now it's only industry one that behaves that way, that crashes to this point over here, and then it recovers through restructuring. What is the restructuring here? Nobody invests, no entry, gradual exit of existing firms until the number of firms becomes again in line with the size of the market. At that point, this industry has converged back to the threshold for activation of gross entry. And at the same time, by definition, by construction, expenditure per capita has returned to the Y-star value because now we are in the free entry regime. Then this industry keeps moving to the right, at some point reactivates firm innovation, and then converges to the steady state. Okay? So in these slides, I have essentially the algebra behind that phase diagram, including the solution for the duration of the structural slump. Because remember the intuition here, we can compute the duration because we know that the recovery is essentially governed by this exogenous rate of exit plus this exogenous growth rate of the population. And we have the differential equation that has a solution. But the important thing is that this date is completely dictated by the parameters of industry one. So in order to figure out the recovery, you need to know which industry is in trouble. Okay? All right. So, and then what happens is that you can actually ask what's happening to the other industries. Okay, the other industries now are seeing a expenditure per capita that follows a path, the interest rate that follows a path. And those two paths, in fact, manifest themselves in the industries J different from one as a time path of their own market size and the interest rate that they face. And they respond to that particular impulse over time. So you can construct the dynamical system representing the response of those industries. And this is just to show you that there are those equations. Each industry has its own industry-specific law of motion of firm size, and each industry is responding to the aggregate, to how the aggregate shock, industry one is in trouble, manifests itself across the economy. And you can account for the activation thresholds of R&D. And so let me show you in the phase diagram what's happening. So in the other industries, you can construct trajectories like this. You can see read this picture as an example of three different industries responding differently to the common shock. Industry one got in trouble because of some reason. And the reason why the response is heterogeneous is because these industries are heterogeneous in terms of their fundamental parameters. So there could be an industry that responds this way, an industry that responds this way, never shutting down entry. This is an industry in which cross entry is always active. And there could be industries that don't shut down firm growth. Why? Because these are industries that somehow are experiencing a boom. Okay? And I'm going to give you an example how to engineer something like this. Okay? So, how to engineer a response like this? We can play with the fundamental parameters and construct a structural reallocation shock. Okay? Defined as, for some industry, from some reason, the industry shares are initially phi j superscript 0 to denote the initial industry share. And then industry one, the expenditure share of industry one jumps down. Okay? Again, you can think of stories to microphone this. Let's see what this gives us. So the expenditure share of industry one goes down, and by construction, the expenditure share of all of the other industries go up. So that's why I call it structural reallocation. What happens if phi 1 falls too much? Phi 1 falls too much. Well, industry one can find itself exactly in the condition, this condition that resembles the structural slump that I just described. Can I engineer the same kind of story through other parameters? Of course. I can leave the expenditure shares as a constant, and I can imagine a technological disruptive event in industry one of the type the elasticity substitution across products in industry one has dramatically fallen for whatever reason. We have learned what that shock does from the baseline model that gives us that because of that increasing competition due to the lower price elasticity of demand, excuse me, higher price elasticity of demand. Firms have lose market power. Because of that loss of market power, then in industry one, firms are in trouble. We need restructuring. Then we go through the structural slump. But in this example, the terminal point of the transition has industry one growing faster than it was initially. So this model generates through these corner solutions and these kind of properties a interesting concept of restructuring that has the a particular industry go in this roundabout fashion to the new higher steady state, but needed to go through a restructuring period first. Why? Because the number of firms is a predetermined state variable that changes only slowly. And in some cases, it needs to go down, and you need to rely on this exogenous process. Why? Because the sunk entry cost gives us a zone of inaction where firms are making positive gross profits, but not high enough to justify entry. And that's the zone of inaction where you need to rely on the exogenous exit to drive the restructuring. And that maybe has a policy implication. Okay. All right. So those are two examples of how you can engineer that kind of transition path. And this slide is simply articulating the point that I made earlier, that by definition, when the free entry condition no longer holds in an industry because of a particular structural change to the economy, then by definition, that industry is experiencing a crash in the stock market valuation of the firms. And that crash is due to the fact that in that market, given the new market size, there are too many firms. And that industry needs to go through a round of restructuring. All right, now, I told you the concept of what is this industry that experiences a boom? Well, this is an industry that, for example, when there is the structural change due to the change in expenditure share, with expenditure share of industry one going down, this could be the industry that benefits for a very large increase, sufficiently large increase in their expenditure share. And this kind of reallocation of expenditure shares could be very easily engineered by the government, for example, through some kind of scheme of tax and spend, if we are willing to complicate a little bit the outer layer of aggregation of the model. Okay, so that's what we get here. Now, the point that I made earlier about contagion that might tell us that the problem starts in industry one, but then it propagates through the financial contagion that comes from the household, the loss of wealth. Then industry two can get in trouble. In fact, we could imagine a situation where there is a cascade of this transmission of these events, and then the entire economy gets each industry in the economy is in the situation where the free entry condition doesn't hold. That would engineer a much longer recovery process. Now, that recovery process, in fact, looks a lot like the predictions that this model has for secular growth. So what is secular growth in this model? First of all, I'm going to shut down the exit rate because I don't need it for this exercise. Same thing that we did in the baseline model of a single industry economy. Now we're going to start all of the industries in the extreme left of the phase diagram, where the market size is so small that there is no investment. And remember that this theory says that the only reason why there is growth in the economy in that situation is Smithian growth, driven by the exogenous population growth. And remember that I don't need exogenous population growth forever. I need a burst of population growth, even for a finite time period. I can write down the process in many, many different ways that preserve tractability. All right, so now we're going to have an economy that looks like every industry is in the pre-industrial state. But because of the heterogeneity in the thresholds, in the activation thresholds, I can construct a very large number of examples. So let's go with a very simple one, a three industries economy with thresholds ranked this way. Okay, I can mix things up and get stuff going, but let me start with the claim. There is industry one has better parameters encouraging driving entry. So industry one activates entry first. Then industry two is the one that has the second best set of parameters attracting entry. So it goes second. And then industry three activates entry. Then I do the same thing for the activation of firm innovation. Three thresholds. I rank them. This is me as the omnipotent dictator in this world, and I want to know what the sequence of events activate, blah blah blah, look like when I want to think of this as the process of growth of the entire economy. Okay, so that's the exercise we're doing here. Again, I'm going to spare you the math. The math is there just in case that people then want to check the equations on their own time as they watch the video. And if people want the slides, absolutely, I'm very happy to share them. The important thing is that at each step of the iteration, you always go through the exercise that I showed you earlier. You look at the definition at the budget constraint of the household, you unpack wealth, you say which industry is in which industry the free entry condition doesn't hold, initially in all of them, and you do your derivation. And what you do then, you derive an expenditure function, an associated interest rate as a function of state variables in the system. It turns out that you can write things in a very, very tractable fashion. For this exercise, it's more convenient to write everything in terms of aggregate market size. And so you get an expenditure function that features this exponential term that represents the growth rate of the population. That's a Smithian, the population growth that is pulling everything up, and it manifests itself as higher productivity through the static economies of scale of the model. That's why I call it Smithian growth. Now, because that's an exponential process, then it's guaranteed that you cross the first threshold, then you cross the second threshold, then you cross the third, and then if parameters are such that each of the three industries satisfies its own endogenous growth condition, then the process will go through another sequence of three activations in which industry one goes first, industry two goes second, industry three goes third. And you can mix the order there. You just recompute things accordingly if you have the taste for that kind of thing. So this is just to show you that analytically, we still can pretty much write everything in terms of the time path of the variables that drive the process. Industry specific, firm size. And these are industry specific. So they don't look the same. Qualitatively, they have the same form, but quantitatively, they will look differently if you calibrate the model. The activation dates are going to be industry specific. And again, we can compute those dates. It just takes a little bit of patience. You sit down, you look at your equations and do the algebra. So the industrial era, let's say the industrial era starts when at least one industry has entered its own industrial era. Okay? That's the first time that we see an industry in free entry equilibrium. Then you redo all the calculations that you do for the previous exercise. And again, you can compute a function giving you the evolution of aggregate market size. This is aggregate consumption expenditure in the economy. And again, it's driven by this exponential function of time. Notice that now your calendar time starts ticking at Tn sub 1, which is the event industry 1 has crossed over into the into the industrial era. If we believe the historians that tell us the industrial revolution started with the cotton industry, then that's your cotton industry if you want. Or I don't know, the steam engine industry, they use the steam engine. So you keep going, and then eventually you get the activation in industry 2, and then and again you have your equations describing the state variables a function of time. Then you get to activation in industry 3. Same structure, the mathematical structure remains always the same. You are just changing the number of inputs in the two components, industries where the free entry condition does not hold and industries where the free entry condition holds. Then when industry 3 enters the industrial era, now your entire economy is in the industrial era, and the free entry condition holds everywhere. Things become much simpler because you get to the free entry regime. And again, you can calculate the time of all these events. So when you are in the industrial era, let me call industrial era phase 2, you are in a free entry regime. All of your calculations become much, much simpler because expenditure per capita is constant, the interest rate is constant, and you go through these sequences of activation. Every time you have an activation, you have an acceleration of the economy growth rate, because yet another component of your economy, yet another industry, now is growing faster than before because of this event that I call activation. Okay, so that's what's happening here. So mathematically speaking, the growth function as a function of time, because it's easier to write things as a function of time in this exercise, you go through this cascade. Between time 0 and time t(n)(1), the beginning of the industrial era, you have the output growth is 0. Then you start adding variety growth in industry 1, weighted by its expenditure share. Then industry 2 starts investing in product variety expansion. And so you get the weighted sum of the growth rates of product variety in those two industries. Then industry 3 enters the industrial era, you get the weighted sum of product variety growth in all the 3 industries. Then you start adding industry by industry the activation of firm growth, vertical innovation, and you have the times at which this happens. Okay. And again, this is the sum of 2 weighted sums. The weight is always the expenditure share of all these things. All right, and I like that this looks like some sort of a big triangle, pyramid, or whatever. So this slide in words repeats the fundamental insight that we are obtaining here. In a multi-industry economy, with fundamental heterogeneity across industries in the deep parameters, you get a sequence of activations that translate into a sequence of accelerations. And so, because I'm a Led Zeppelin fan, you get the stairway to growth kind of scenario. And again, you can construct this. I can't imagine putting this model on the computer because it could be very daunting. But the beauty of quasi-analytical solution, actually these are analytical solutions, is that we know what the output needs to look like if we try to put this model on the computer. And I have no prior on whether the stairway to growth should look concave or convex, S-shaped with initial convexity, because that's entirely possible. And when I was an undergraduate, I saw many pictures like this drawn by hand, people representing the growth process as a sequence of moving from one industry to the other, but never fully microfounded models with an analytically tractable structure. So that's Now I forgot about doing that. I was planning to play Stairway to Heaven as as I showed you this, but that's the final slide I want to share with you today.
Well, that's great, Pietro. Really great. And yeah, I mean, it would have been very nice to end it with Stairway to Heaven and not with Highway to Hell, perhaps. So,
Well, that's Carmelo's question about the
yeah.
policymakers screwing things up.
As an AC/DC fan, I'm very likely to ask such a question in any case. Yeah.
Yeah, and great. I mean, that exactly is what I had in mind when talking about this earlier, just with different industries, and then you would have this weighted average, right, over these industries, and then perhaps you would also have a structural transformation where then one sector becomes more important, the IT sector, for example, over some time. And yeah, I find that's really interesting. Yeah.
Structural transformation is a fantastic point to discuss, but it's also very dangerous because, as you know, the structural transformation literature has a very well-defined structure, set of models that they like to use. And typically, they think of the structure of the economy as the traditional agriculture, industry, services. I could call these three industries agriculture, industry, services.
Yeah.
Because of the outer layer of Cobb-Douglas aggregation, the expenditure shares are constant, those expenditure shares. But if I look in real terms, so let me call the nominal, but remember that the industries are growing at different rates. So when I look at real terms, this model, in fact, has a very large amount of transformation, qualitative change in the weights that change that I could call structural transformation. But I'm hesitant in using that terminology because that terminology belongs to a very well-established literature and it might create confusion using that term. What it is true is that along this process, even holding constant the expenditure shares of the outer layer of aggregation, Cobb-Douglas, because of the parameter heterogeneity, the three industries are growing at different endogenous rates and converging to different endogenous steady-state growth rates. So in real terms, it is entirely possible that one industry takes over the entire economy in real terms. In terms of expenditure divided by the price index, not in terms of employment, because the industry employment is aggregate employment is always LJ equals 5J times total workforce. So there is discipline in the part of the model. This is probably where this apparatus really is not directly comparable to the structural transformation literature. In the literature, in order to get some action of this type, they first of all, to my knowledge, nobody does endogenous growth there. And secondly, they had to go to allow some differential growth rates of exogenous productivity growth, preventing the economy from going to, because they had the CES operators, to have the time varying sectoral shares to prevent one sector, the fast growing sector, from taking over the entire economy. They needed to go to these more complicated demand systems with translog and all the other stuff that has become popular recently. That's one way to do it. So I don't think that what I'm doing here is directly comparable.
Thanks a lot. So are there any questions?
Yes, I have one question that is related to the possibility that, for instance, many industries, or maybe all industries, fall into the no firm entry region.
Yes.
So, if this happens, what kind of policy we can implement in order to speed up the process of recovery?
There are lots. The graphs, the phase diagrams are useful in the following sense. They tell you that when an event like that happens, there are two classes of policies that you can think about. Let me call them the traditional macro policies and then the new IO-based kind of policies. Yeah. So what I mean by traditional macro policies, interventions that can change aggregate market size and therefore through the expenditure share, the market size of the particular industry. And those would be policies that show up in the aggregate, but in the budget constraint of the household. You can think about temporary lump sum transfers to the household. You can think about temporary relief, reduction of the tax rate on wages, a bunch of things that enter through the channel. If you have a tax on consumption, then you can play a very long list of instruments that one can use. When you think about action that can target the individual industry, then you don't want to think necessarily about corporate tax rates, because those tend to be set equal across industries. They're not industry specific. But you can think about Pigouvian tax rates, subsidy rates. For example, you can use the expensibility of R&D, which is a sort of implicit subsidy to R&D. And the rate is the expensibility rate times the corporate tax rate. And so you can imagine that you can, because that tax rate shows up in the graph moving to the left, the activation threshold of firm innovation. And again, the model gives you information about at the industry level about these things. And then you can think about other policies that direct subsidies to R&D, not just through the expensibility rate. To an extent, the government, I don't have it in these slides and in the kind of models that I'm working with in the book, but you can imagine that you can extend this apparatus to the demand for the product of the particular industry now has a government component, and then government purchases targeted at a particular industry can directly affect the size of the market. The same way as a government engineered structural reallocation of expenditure shares can create the problem in the first place. So all sorts of things of that sort are possible.
Okay.
The speaker is quite tired. No.
It's okay.
No, yeah.
The speaker is quite tired. I see him, really tired.
Well, just to give a chance maybe to Pietro to take a breath, then
To survive, I'd say.
and to survive. Actually, I'd like to make a comment here, because here I see a solution to an issue that we were dealing with Pietro in some early work about the industrialization and the role of corporate governance into industrialization. And in fact, here I can see that this structure gives much more flexibility in timing the path of industrialization through these sectors, getting in step by step. So that I think it's a very gives a lot of flexibility. That's very nice. And a more general comment, I guess that the interpretation of this model is about a more articulated economy with some heterogeneity in industry. But I was also thinking that they could also be interpreted as a model that can be applied to the world economy, that is interpreting one economy as being characterized in a more stylized way through one or two or a very small set of industry, and another economy through, say, another small set of industry and so on. And that would give more, I guess, the picture of the transition of the whole world, not necessarily by, because the world is still interrelated through the industry in the same way this model, I think it's depicting. That's an
Yeah, no,
interpretation.
we already have applications of this framework to international trade.
All right.
I have a paper, then Simone Valente and I have
Okay, sorry. So I was not.
but
not
the intuition
knowledgeable.
is interesting. The intuition is correct because in some way nothing prevents me from calling the industries that I just showed you countries,
Mhm.
and with some Arbington assumption and that kind of stuff. And I don't see the way the framework works. I don't see any reasons why I should break down when, on top of the experience that I had working on the papers that I worked on in the past, nothing tells me that the framework should break down under the stress of dealing with heterogeneous countries. Your intuition is correct. I just showed you how to deal with heterogeneous industries. Probably the same solution procedure and approach works for heterogeneous countries. In fact, I have a couple of chapters on in application to international trade of these models. One of them builds on my previous work with Simone Valente.
Great.
Yeah, I think then let me thank you again for these great presentations and this set of very nice and illuminating lectures, Pietro. Really, I'm very grateful. And as I said, I will upload these two lectures from today on Sunday and on Monday, and then afterwards all four will be present, and I will do a playlist with this lecture of yours as a kind of growth lecture, and then also share it widely. And let me also thank to everybody here for their interest, and particularly for Antonio also for organizing it and for recording it. So that was really great. And yeah, I hope we will soon have the chance to meet again somewhere at some place. And it would be great to talk to you again in person.
Fine.
Thank you.
Thank you so much.
Many thanks,
Thank you.
Pietro.
Thank you.
Bye.
Thanks so
Thank
much.
you.
Bye bye all.
Bye. Bye.
Bye-bye.
Goodbye.